talking about empirical and molecular formulas. So when given a percent composition and not a formula, so you're just told it consists of 11% oxygen and this much percent hydrogen, you can actually figure out the empirical formula from that data. And I'm going to show you how to do that today. So empirical formulas then, the difference between an empirical and a molecular is that an empirical is in the smallest ratio it can possibly be. So for example, do you want my keys and to come in the back door?
Go through the door.
Yeah, I think it would be easier.
Don't worry, Ben's good.
Here.
I was ready.
How is he supposed to get back there?
I can push. Oh, that was the part that was good.
Okay, so an example of an empirical formula would be, get this to, would be CH2O. Okay, the molecular formula for that would be C6H12O6. This is in the simplest ratio of this. Everything here is divisible by 6. So this is your empirical, this is your molecular. H2O2, what would its empirical formula be? HO, okay? Because everything is divisible by 2. Some things are the same. So you can't get simpler than this. So the empirical formula of this is its molecular, okay? But a lot of times you can get simpler. So this is empirical, this is molecular. I'm going to show you how to calculate both of these today. All right, there are steps for it. So step 1, if you are given a percentage of the sample, sometimes you're given grams and then you can skip down to number 3 here. But if you're given percentages, you're going to assume that you have a 100-gram sample, and then those percents are your grams. Then you change your grams to moles. You divide each mole value by the lowest mole value listed. If there's decimal numbers, then you're going to multiply by a whole number to get up to a whole number, because you got to have whole numbers. You can't have formulas where you have like C3.5H7. Okay, that doesn't exist. Okay, you can't have half of an atom there. Okay, so that's not going to work. And then you're going to create a ratio and use those ratios as the subscripts. Now, this is very wordy, so let me take you through a couple examples of this. Okay, so step 1, assume you have a 100-gram sample. Step 2, turn your percents into grams. We are through the first 2 steps now.
Let's go.
Okay, so easy enough. Are you with me so far? Assume you have a 100-gram sample, change your percents into grams. Now we're going to convert. Step 3 is convert the grams into moles, and we learned to do that last week. So we're going to take 36.84 grams of nitrogen. I'm going to divide it by the molar mass of nitrogen on the periodic table, which is 14. And that's going to give me moles of nitrogen. I'm going to do the same thing with my oxygen. So 63.16 grams of oxygen. I'm going to divide by 16 off the periodic table for oxygen. And that's going to give me moles of oxygen. There we go. 36.84, 14. We end up with 2.63 here. 63.16, 16. I end up with 3.94. And you should really keep these at least to 3 sig figs. If you're not keeping these to at least 3 sig figs, you're going to run into some problems. Guaranteed. All right. Everybody up with me so far? Have I lost anybody? Okay. Step 4, you're going to find the lowest mole value here. So which one's lower, nitrogen or oxygen?
Nitrogen.
You're going to divide everything by its mole amount.
Okay.
So this one's pretty easy. That's a 1. And here I end up with 1.50. Okay. Now, if these end up being whole numbers, at this point, those become your subscripts. But this isn't a whole number here. So I can't have NO 1.5. Okay, that doesn't work. So what you have to do is you have to multiply both of these. This is step 5. You have to multiply both of these by something that'll get that to a whole number. So what's the smallest thing that I can multiply these by to get it to a whole number? 2. And I have to do it to both of them.
Wait, this is crazy.
And these then become my subscripts. So N2O3. That is my empirical formula. Easy enough? You have to follow the steps. Gots to. All right. Next problem. Step 1. If you're given percents, assume you have a 100% sample. Step 2. Turn your percents into grams. Step 3. Convert these into moles. Oh, over there. There we go. All right, these are my mole values. Now, this is where people oftentimes end up kind of goofing. They skip this next step. They see this and go, oh, I'm going to multiply everything by 3. Or, oh, I'm going to multiply. No, the next step is not that. What is the next step?
Divide by the smallest thing.
Divide by the smallest mole value. So this is 1.33. 1.33. So this equals 1. And this ends up being 1.50. So now what do I do? Right? What is the smallest number that I can multiply both of these by to get them to a whole number? 2. So I'm going to multiply both of these by 2. This ends up being 2, and this ends up being 3. So then my formula is Al2S3. And if you look at this guy, if you go back to the stuff that we've learned already, this is a +3, this is a -2. Does this formula make sense?
Oh, same from that first one. Nitrogen is 3 and oxygen.
Well, that gets a little sticky because this is covalent bonding, and that gets kind of weird. But this is ionic, so this works well. All right, let's see how you do. I want you to try this one on your own, and then I will show you how to do molecular on the next page. Nickel. Wait. 2.
Do we ignore the 100-gram sample for this one?
Well, yeah.
Okay.
This is already in grams, so you skip right to step 3 for this guy. Because you don't have to, it's not in percentages. So they've already given you your grams. They've already done steps 1 and 2 for you.
Mm-hmm.
Divided by 14. Okay, so that guy. Divided by 2. Okay. Okay. That's good. I would keep these to 3 sig figs. Those are 2. So just telling you, like, in the future, it could get leaky. Can you put those labs out in the center of the room so that we're ready to go for 5th hour? Thank you, sir. A little bit of spring to. You have to. You're like the mother, and you have to make sure that it stays safe all the time.
And I'm gonna give it to my friends.
Oh, it's so pretty. That's nice of you. Good.
Very shiny. Like it's coated in gold.
She's so happy. Freezing it.
I've heard.
What?
Burning. I've heard. Burning. I used to have a plant. It is. It never worked. I had to water it. And touch it.
Oh, you said burn.
Burn. I've done that too.
Do you need to see what's in each station?
No,
Remember which station it's with? Here's the last.
Because I had a plant and I burnt it. Because it made a rough.
All right, is this what you got for your answer?
Burn?
Pretty much.
Oh,
What are you
yeah.
saying?
So, did you recognize that cyanide was one of your polyatomic ions? This would have been like in middle school where they had the 3s and 4s. You remember that?
No.
This would have been your 3. This would have been your 4.
I did like it.
Both are right. I'll take both. I'm not that picky, but that would be like your 4. Does that make sense?
Okay.
All right. Anybody not ready for molecular? Okay. So molecular is just one extra little bit of a step beyond empirical. So to do molecular, you have to figure out empirical first. Then they have to give you the molar mass here. Okay? And from that, we can get the molecular formula. So let's start here by figuring out the empirical formula for caffeine, one of my favorite substances in the world. All right, we were given a 100-gram sample. They've already broke this down into grams for us. Figure out the empirical formula for caffeine. You guys should be able to do that, and then I'll take you through B here to figure out the
He used to.
Yeah, he's dead. He
Oh,
died.
you want- you made them something?
He died. No, he died. He's a monkey.
It was a monkey though?
He was a monkey. He died. It was so sad.
All right, are you figuring out the empirical formula for this guy?
No, he was held in his presence.
Monkey guy.
He was killed in his presidency
Peru.
of Peru. He was a beast.
Peru, Wisconsin.
No.
Is that a real place?
That was Peru,
You could
Illinois.
have visited it.
You can visit Peru, Illinois. That's a cool place.
Oh, I think it's by Stephen. Peru.
I have, what is it called?
I think it's by
So in
Stephen
Peru,
Cody. Good
Illinois,
stuff.
I had to get ice cream and I had an ear infection and we were driving in a car for 5
Pull
hours.
over, I saw Peru.
And I was like a weird thing, screaming, oh no. It hurt so much. Because we did not.
There's a Peru in like half the states in
There's an Ohio, Wisconsin.
That's
Oh.
dumb.
I was really confused when my mom said we were going to Ohio for dinner.
That's funny. Ha, 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 ha.
Wow.
That was true. I was being truthful. I
Yeah.
stayed truthful.
I can tell. That was funny.
That was truthful.
That's your real life thing.
No, you know my real name.
He raises the salad.
That's coming
Do you have your empirical figured out yet, guys?
That's true.
All right, let's see here. I had C4 N2 OH5.
Yay.
That's what I was like.
What I got.
I did get that. I was just saying, I don't know if the maths was-
Anybody not get that?
Then
Oh, I did. Look at 4, 2, 1,
it's
5.
C4.
I do like C4.
Over there.
Good grade.
We didn't do the actually. No, we didn't.
I didn't
I'm gonna go
hear the
combine,
people
guys. I'll be
who
back.
shoot fellowship together.
I haven't even done that.
Standing outside Dr. Dion's office, just screaming the pledge.
Oh, we didn't do pledge today, did we?
Yeah,
Oh
we
my God.
All right.
didn't.
Anybody not up with me now? David, you here?
You
You got this? Okay. Let's go back to the chat.
What then? So
So you're here. Now you're gonna divide everything by 1.03. So this will end up being 4. That'll be 2, 1, and 5. And that's where we go.
Okay, but actually 8 people got a 0 out of 10.
All right. Anybody else not have that? Okay. So now we're ready to look at the molecular. Okay. And this is easy. So to find the molecular, what you do is you're going to find the mass of this guy. So find 4 carbons, 2 nitrogens, an oxygen, and 5 hydrogens. So find the molecular mass of that. So 12 times 4 plus 28 plus 16 plus 5 is 97, yes?
Yes.
Okay.
No, what did you do? There.
Okay.
I
right.
had a plus and it said error. No.
So this is the mass of my empirical. I'm going to take the mass of my molecular, which they gave me here. So I'm going to take 194.19. I'm going to divide that by 97. And I come out with?
Don't do it. I want to see. Okay, you can say it.
2.
2. Okay? So now you're going to take that 2 and you're going to multiply all of these subscripts by 2. So C8, N4, O2, H10, we have caffeine.
Yay! Good job, everyone.
And that's the end of chapter 10.
That is?
Yep.
Let's go.
No, it's not. I forgot we have hydrates.
Don't we have a lab or something?
Yeah, we got hydrates too. I forgot about hydrates.
Carbohydrates?
No. All right, let's try one more example, another example here. We've got malic acid. Okay. So you're going to find...
Wait, you have 0.7 left and you didn't tell me. You're kidding me. Wait, does this take 0.7? 1 second. This might take 0.9 left.
You're going to find the empirical of the malic acid. Then from there, you're going to figure out the molecular formula for it.
0.9.
But if you can do empirical, then hydrates are super easy.
No.
All right, let me figure this out. Carbons, so 41, 39. So 3.44. 416. Okay, so empirical is CHO.
No. Yeah. Oh. Okay. I'm thinking. No. One.
Wow. Oh. So should I not finally, or should I have one more sick day?
No, 3 sick picks is fine,
Oh, okay.
but everything's gonna divide out and be 1, so, I mean, you kind of look at that and see what's gonna end up being 1, right?
You're right.
Cho. I don't think that's a thing.
Cho Chan Chong.
Cho. What?
All right, so I went and I divided each of these by their molar mass. This would be by 1, and this would be by 16. And then every one of those came out to be 3.45 or 47. So dividing by the lowest mole amount, every one of them comes out to be the same, and it ends up being 1. And then once we figured that out, we could figure out the molecular mass for this, which is 29. Divide this by 29, that equals 4. And so then we go through and we multiply each of these by 4. Good?
Sounds good.
All right, one more. Silver oxalate. You want to know what its molecular mass is? We're going to convert these into grams. I got 7.91 divided by 12 and 21.07 divided by 16.
Oh, wow, silver's a hefty one.
Yeah, it's a heavier metal.
We're doing a lot of stuff. We're taking notes on national. Right,
Then this notes on Friday too.
I know. Oh, wait, what did we do on Friday?
This notes more better.
I don't. Was it? It was. Yeah.
Oh, it was GDQ again.
I didn't rewrite it yet. 21.07 divided by 16. Woo.
There's so many zeros in. Oh, no, you know.
Divided by. What is it called? What is it? 5.658. So it's
1, 1, and 2. Because we're going to divide this by 658.
Oh, this one's 2.
So AG CO2. All right. So then we figure out the molecular mass of that. That's going to be 107.9 plus a carbon plus 2 oxygens. That ends up being 151.9. 303.8. 151.9 equals 2. So AG2C2O4.
Ooh, we're done.
Good? Is this making sense? All right, so you got some practice with these tonight. I think it's only a few problems. I don't think it's like, I think it's just 1 page. 11 problems, so it's 2 pages, so 11 problems. So that's your homework for tonight, okay? And then tomorrow we cover hydrates, and then we do a lab for a couple days and have a test. And yeah, or no, we don't have a test on this, do we? We're just gonna move right into stoic. I combined the 2 tests, so yeah, that's where we're at.